Hi everyone, Tim here. Well, today's video is going to be the first in a series of videos that will deal in electronics. What we'll do is we're going to start out with some very basic terminology, and today's video will be on current. The next video will be on voltage, and then we'll do one on resistance, and we'll try and tie it all together, do some Ohm's law equations and stuff. So let's get started. We will get in depth on a lot of this stuff later on in the course. What this is designed to do is just give you the briefest introduction to some of these terms like alternating current, direct current, and voltage and things like that. And some of them will be chapters all in themselves. So what is electrical current? That is the flow of electrons through a conductor. Now, when most of the electron movement takes place in the same direction, so that one part of the material loses electrons and the other part gains it, that net movement is called current. And what happens is the electrons in the negatively charged electrons in the outer shell there will be traveling from one atom to the other. They'll hop across there. When that all happens in the same direction, that is electron flow. That is current. How fast are they doing that? That would be the electron velocity. Now, all free electrons in conductors start moving almost immediately when you apply an electrical field. The actual velocity of that, or drift, is actually quite slow. Only one electron will move in a small fraction of an inch per second. But the effective velocity is about 186,000 miles per second, which is about the speed of light, pretty close. And this happens because when you move one electron on the one end, it bumps the other at the far end, so the net effect is, it happens very quickly. And what is it flowing through? Well, it has to flow through a material called a conductor. Now, a conductor is a material that has the ability to transfer charge from one object to another. And it does this because it has the ability to remove electrons from individual atoms and transfer them to the next. Copper wire is a great example of it. So is silver, aluminum. A lot of metals are good conductors. And if you have conductors, you need something to insulate yourself from them. And there's a series of materials called insulators. Now, what an insulator does is just the opposite. It resists the flow of charge. An example of some insulators would be wood, rubber, glass, and dry air. And then there is, in between conductors and insulators, is a material called semiconductors. And there'll be a whole separate chapter just on semiconductors themselves. This class of materials is intermediate in between there, and in their ability to transfer the charge. An example of that, some of the materials would be like germanium and silicon. Next, we'll talk about the amp. And the amp, that is the SI unit of electrical charge, and that is what we measure electrical current in. Remember, current is defined as the rate of flow of a charged particle through a conductor in a specified direction. And the rate of flow of charge is measured in coulombs per second. 1 amp is equal to 1 coulomb of electrical charge passing through a certain point in the electrical circuit in 1 second. So if we look at that in equation form, it is designated by the letter I, capital I. And I represents current in amps. So we're looking at I equals Q over T, where I equals current in amps. Q is the charge transferred measured in coulombs, and T is always the time in seconds. So we have direct current and we have alternating current, and what the difference is here, the big difference is direct current travels only in one direction. And you can see there it's traveling from the negative end of the battery and going around. That's the way the flow is going on that. As the difference you can see here on alternating current in that diagram is showing that the current is going off in both directions. So if the magnitude and direction changes with time, it's referred to as alternating current or AC. So that's a big difference. And we will get to talking about sinusoidal waves and things like that, and the amplitude, and there's just a lot of stuff to cover in AC current, and that's going to require a whole chapter on itself. Then there's also a pulsating current. If you and what that is, if you take a unidirectional or a DC current and it changes the magnitude with time, that's called a pulsating current. Now you can see on the top diagram there, that would be an example of what that looks like. It's very similar there. That looks like a waveform from an output wave shape from a rectifier. And a rectifier is a device that will you can change AC current to DC current. And I'll probably do something and get a lot more in depth into rectifiers, but just know that has the ability to cut. What it does really is it cuts a sine wave in half and just takes part of that, and that will give you the DC component of that. So that's all I got for today, and we'll get to more of these in depth. The next video is going to be on voltage, and then I'm going to do one on resistors, and then probably follow that all up. We'll tie that all together and discuss all Ohm's law, and probably go over the Ohm's law power wheel. So thanks a lot for watching. I appreciate it, and we'll see you soon.